How's it going, everybody? In this video, we're going to take a look at our next topic, which is going to be OSPF version 2 and version 3 sham links. So this is supported on both iOS and XR. And one of the things that I'm going to go do is I'm going to convert our peering from CSR1 to R13 and XR9 to R14 to be OSPF version 2 and version 3 peerings. Oh, I just noticed that I'm see-through. That's kind of cool. So we're going to do that, and what that's going to allow us to do is test out a kind of, I won't say, well, I guess it's kind of an advanced feature, but it's a traffic engineering capability, where if I was to convert the connection between R13 and R14 to be an OSPF peering, so convert it from EIGRP to OSPF from the previous video with site of origin, what we'd end up doing is the peering here, we would want to, instead of going through this connection between these two routers, for example, we could have this set up as a backdoor path, where the idea would be you have a connection between two different locations, and you want to use that backdoor path as a backup link. So instead of sending the traffic through directly here, maybe it's a slower speed link, maybe it costs you more, maybe it's a dial on demand type of circuit. It could be any reason why you want to go that route with it, but you would rather send the traffic over the backdoor connection between CSR1 and XR9 in order to interconnect R13 and R14. Maybe this is a higher speed circuit. Maybe it's got better QoS for certain types of applications. So whatever your business drivers are, I'm not going to get into all those different use cases that I just mentioned, but it's one of those things where you could very simply send the traffic this direction, and go that route. So what I'm going to go do is I'm going to go through and set the peering up between CSR1, R13, then XRV9, and R14. We're going to get OSPF version 2 and version 3 up and running first, and then we're going to walk ourselves through the steps to set it up for the sham link. So I'm doing this from the get-go as a brand new implementation so that you guys can see exactly how it's done from start to finish, instead of, oh, hey, I already have this done. I want to make sure that you guys can follow along as we're going there. So in order to accomplish this, we need to do a couple of major things first. So we're going to pull up XRV9, and what I will do is bring up this connectivity, and I'll go on XRV9 first. I'll set the peering up between 9 and 14 first. So we're going to go ahead and log in. If I could type in the right username and password information. There we go. Go to global config. And currently, I should have a BGP peering, so do show run router BGP. And I do have a peering. So I'm going to type in router BGP 100, and then I'm going to go underneath VRFC1. I'm going to pull this neighbor out, and I'm going to do the same thing with this peering here. So I'm taking down the BGP peering. So I'm going to go ahead and I'm going to commit that, and then I'm going to go over to R14 and show run pipe include router, and I can shut down the BGP peering. So I'll just turn BGP off. I can't turn BGP off on the other router, so no router BGP10. That'll take care of that. On CSR1, we'll do the same thing. So do show run section BGP. And we'll go underneath router BGP 100. And then underneath address family IPv4, I'm going to go ahead and basically pull out this no. I'll pull out this redistribute ISIS as well. And then underneath address family IPv6, we'll do the same thing there. We will remove the RIP config and the ISIS config, and do show run section BGP. That gets us down to, go ahead and redistribute ISIS and pull that out. And then we're going to go to R13. And we'll do a show run pipe include router. We'll turn BGP off. No router BGP10. All right, cool. So now we're squared away. And what I'm going to do is a show IP route, and we are going to have the 10.14 prefix is learned through EIGRP. So the way we have it set up now is we have EIGRP. So I'm going to go ahead and swap the connection between R13 and R14 over to OSPF. So to do that, we're going to go back to global config. We're going to type in router EIGRP MPLS address family IPv4 autonomous system 10. And I'm going to specify underneath topology base, we would go in here and we would set the distance for EIGRP for internal routes is going to be 125, and for external routes it's going to be 125, and hit the enter key. Do show run section EIGRP, and what should end up happening is once I do this command real quick, we go over to 14, do the exact same thing. Notice how the adjacency changed. We're going to go ahead and we'll apply that config as well. So now we go back to 13 and we jump and look at the routing table. We should see now that EIGRP is coming across, and we can see that the administrative distance is now 125. So that's going to sync it up, and that's actually a good thing for us because that means that both sides of the configuration have taken place. So now we've changed the default administrative distance from 90 to 125 for all EIGRP routes. So what we will do now is I will go to, we go over to 13, or I'm sorry, 14, router OSPF, and we'll say 10. We'll type in network of 10.0.0.0.255.255.255 area 0. And we'll take that same config and put it on 13. 13 should be done just about now. I'm going to try to cancel this connection real quick. So I'm going to go back to global config router OSPF 10 network of 10.0.0.0.255.255.255 area 0. So what will end up happening is eventually 13 and 14 will form an OSPF adjacency with each other, and they'll exchange the routing information. So we'll no longer see the routes, the R13 and R14 loopback being advertised to each other via EIGRP. It'll be OSPF, which is what we want. So we're making sure we're setting all these details up and getting that squared away. So we'll go ahead and give that a couple more seconds. Okay, the EIGRP adjacency is up, so we do a show IP route. Now we're going to be learning the now, this goes back to when we were looking at OSPF as a PE2C writing protocol. You'll notice that the /24 prefix is coming across as a /24, but the loopback address itself, the /32, is coming across as an OSPF learned route. So what I'm going to go do on here, I'll type interface loopback 0. We'll type an IP OSPF network point to point. And then we're also going to go to, on 13, I will go to global config, interface loopback 0, IP OSPF network is point to point. And then underneath we'll type in router OSPF 10, network of 172.16.13.0. We'll put this in as a /24 in area 0. Go back over to R14. We'll jump out of global config, and then we'll do a show IP route. So now everything comes across as an OSPF learned route. Now, a couple other things that we'll have to do before we move on is this is going to be version 2 and version 3, so we need to make sure that we have IPv6 enabled on the connection between these two routers. We'll go ahead and get that done now. So let's go back to global config, and then we're going to go to do show run interface loopback 0. I have an IPv6 address. Do show run interface gig 0/1. Make sure there's an IPv6 address there. There is not currently, so we'll type in interface gig 0/0. IPv6 address is going to be 10:13:14:14/64, and I'll type in OSPFv3 10, and then we're going to specify IPv6 area 0, and then interface loopback 0, same thing. And then I'm going to go over to 13, do the same thing. So interface loopback 0, OSPFv3 10, IPv6 area 0, interface gig 0/1, do show run interface gig 0/1. See if there's actually, and there isn't, so IPv6 address of 10:13:14:13/64 OS, and I can just hit the up arrow a couple times. So now that that's in play, we should have OSPFv3 reachability. So we'll go ahead and give that a couple seconds to come online. Alright, so our adjacency is now up. If we do a show IP OSPF neighbor, we have the peering to R14. If we do a show OSPFv3 neighbor, we have a peering to 14. If we do a show IP route, we can see that we have one OSPF learned route on this side, so 14's loopback. If we just look at the OSPF output, we're going to see 14's loopback. If we do a show route IPv6 OSPF, or show route OSPF, show IPv6 route OSPF, we're going to see 14's loopback. So what that means now is I have the backdoor connection is squared away, right? So we should be in pretty good shape. So now what we get to go do is extend OSPF into the regular routing domain. So we'll go and configure OSPF between 1 and 13, and then XRV9 and 14. So we're going to start on, since we're on 13, we might as well start right here. We'll type in router OSPF 10. We'll type in network of 101.1.13.0, 0.0.0.255, area 0. We're going to go to 14, and we'll also type in interface gig 0/0, OSPFv3 10, IPv6 area 0. We'll get all that squared away. We'll go to 14 and do the exact same thing. Router OSPF 10, network of 9.14.0, 0.0.0.255, area 0. Interface gig 0/0, OSPFv3, IPv6, area 0. I'm sorry, I forgot the 10, IPv6, area 0. And then now we have that done, we already have a peering up to 9, which is good. So we'll just double check on CSR1, do show run pipe section OSPF. So we'll type in router. Actually, let me go and jump out of here real quick. Let's go type in. Now we have autonomous system. We're using OSPF process ID 100 for the internal service provider routing, and we can't use that same process ID for VRF aware routing. So what we're going to go do is type in router OSPF 10, and then we're going to specify VRFC1. We'll type in network of 101.1.13.0, 0.0.0.255, area 0. And then we'll do so that gets us an adjacency there. Then we're going to type in interface gig 3 and type in OSPFv3 10, IPv6, area 0. That interface is already inside of the VRF, so we have those adjacencies that popped up, which is good. And now we're going to go over to XRV9, and we can see, once we log back in, if we look at the show run router OSPFv3, we already had the configuration squared away there, which is good. Show run router OSPF, and so we'll type in router OSPF 10. We'll type in VRFC1. We'll type in area 0 and then interface gig 0.0.0.0.2. And then we'll specify at the VRF level, we'll specify the domain ID of this value right here for that. And we'll commit those configs. And because CSR1 should automatically associate the domain ID. So if we jump out of here and do a show BGP VPN v4 unicast all, we should start to learn those routes. Let's see why we are not. Let's look at the I'm not running BGP at all. So let's look at. Oh, you know what? That's why. I'm not redistributing in back. I'm not redistributing OSPF to BGP yet. That's why. I forgot about that. So on CSR1, if we show IP route VRF-C1, where we should start to see the prefixes starting to show up, which we do. If we do a show IPv6 route VRF-C1, we can start to see those routes coming through as well. So actually, let me go to 13 real quick and type in interface loopback 1 and OSPF there. We'll type in IPv6 address is going to be 172:13:13/64. So now 13 should, so I'm sorry, CSR1 should see that now coming through and any moment now. And there it is. So we see the prefix coming across for all the prefixes that 13 is advertising. And then XRV9, if we jump out of global config, show route VRF-C1, we should see OSPF routes coming across, which we do. And if we look at the show route IPv6 VRF, show route VRF-C1 IPv6, we're seeing routes come across for OSPF as well, which is good. So everything from the provider is seeing the routes that we need to see. So now what we need to go do is on CSR1, we're going to go to router OSPF10 VRF-C1 and type in redistribute BGP 100 and say subnets. And we're going to go ahead and propagate that. We'll type in router router BGP 100 address family IPv4 unicast VRF-C1 redistribute OSPF in OSPF10 and VRF-C1. Now we're going to go to, that's IPv4, so we're going to type in router OSPFv3 and 10 address family IPv6 VRF-C1 redistribute BGP 100 and hit the enter key, and then router BGP 100 address family IPv6 unicast VRF-C1 and redistribute OSPF process ID 10 and include connected. So there's that. So now CSR4, if we look at the show BGP VPNv4 unicast all, we should start to see prefixes starting to show up, which we do. And we see the traffic coming from 13, right? Now if we do the VPNv6, we should also see traffic coming across from 13. Now if we look at, but we're not seeing any routes coming from CSR14 because XRV is not doing the redistribution. So let's go do that now. So we'll go here, we'll type in router OSPF10 VRF-C1 address family IPv4 unicast. We'll redistribute BGP 100 and we will go ahead and apply that. Then we'll go to router. Let's go ahead and do the other portion of OSPF. So it'll be router OSPFv3 10. We'll type in address family IPv6 and VRF-C1 address family. Why is that not liking that command? Oh, area. We'll type in redistribute BGP 100 and do that. So that does all of our OSPF configuration. We'll go back to go back to the global config. So type in root router BGP 100 VRF-C1 address family IPv4 unicast redistribute OSPF 10 and then match on that, and then we're going to go exit out of IPv4 address family, IPv6 unicast, redistribute OSPFv3, 10, and then there we go. So all of that should redo the redistribution. So we have mutual redistribution. We have IPv4 OSPF, IPv6 OSPF, and then the v4 and v6 for BGP. We're going to go ahead and commit this config. And then we'll go up to CSR4. We'll hit this up arrow. So now we're learning, we should be learning more prefixes here momentarily. So we should be learning, so we are learning 10.1.14 from 9, which is the primary path. If we look at v6, we're also learning these prefixes, so we're learning the 14 prefix. So at this time, we have completely gotten back online all of our configuration. So it took us a little bit of time, but we're doing 2 address families at the same time instead of 1. So now what we get to go do is we have to take a look at the configuration from R13's perspective. So if we look at the show IP route, we look at the way that these routes are coming across, you'll notice that to reach to 10.1.14, we're going across this backdoor link, right? And we see this OSPF external type 2 route coming across for reachability to 15, and so on and so forth. So we're not too concerned about actually getting to 15. We just want to focus on getting the reachability to 13 to 14, but having to go through the MPLS backbone versus going through the directly connected link. So we do a trace route to 10.1.14.14, sourcing from loopback 0 numerically. We go directly across the backdoor link, this guy right here. This is where we're going. So but we want to change that up. So in order to do this, what needs to happen is CSR1 and XRV9 need to form what they call a sham link. The sham link is going to be a control plane adjacency, where basically what you're going to be doing is you're going to be having CSR1 and XRV9 join area 0 and extend the information. So we're trying to basically extend the area 0 configuration from the customer side into the provider edge portion of the network. So think of area 0 being here. We also want area 0 to be here. Now what that's basically going to do is that's going to change how OSPF infers the routing. So if we were to look at any of the other routes, and you'll notice that when we look at 13, we can see that the 14 prefix is coming across as an OSPF intra-area route. That means that the domain ID is coming across correctly. If we look at the show BGP VPN v4 unicast all, and we look at the particular prefix of 14, right, we're going to see that the domain ID is coming across appropriately. We see that's coming across. If we look at XRV9 and do the same thing, if we do a show BGP VRF C1 VPN v4 C1, sorry, it's VPN v4 unicast VRF C1, and we look at these prefixes, and we look at the 13 prefix, for example, we'll see that the domain ID is coming across appropriately. Right, I'm sorry, this one right here. The domain ID is coming across. That's what makes on 13 and 14, if we look at the show IP route, that's what makes the 10.13 route, 10.1.13 come across as an OSPF intra-area route. The same thing as the 172.16 prefix come across as an OSPF internal route, and not an E2 or some other variable. So with that being said, now we have to go and we have to form a connection between CSR1 and XRV9. To do that, we actually have to go to CSR1 and we have to create another loopback. So show IP interface brief. We're going to create interface loopback 1. We're going to put that into the IP VRF forwarding of C1, and we're going to give this an IP address of, in this case here I'll type in 10.1.1.1/32. And by doing that, That's going to put it into the VRF. So do show IP route VRF-C1. We're going to see the connected loopback. Loopback 1 is now inside of the VRF. What we're going to go do is on the same thing on 9. So show IP interface brief. And I'm going to go to interface loopback 1. IP address is going to be 10.1.1.9/32. VRF is going to be C1. I'm going to go ahead and I'm going to commit that. So now do show route VRF C1. We're now going to have the loopback inside of the VRF, which is what we want. Now what we have to do is we have to go and advertise this prefix to the other connection, or to the other side. So we have to go into BGP and propagate the route. We can do this with the network statement under BGP, or we can redistribute it. I'm going to just do it the easy way and do a network statement. You could do a redistribute connected and call a route map and specify the loopback. That's another option as well. So I'm going to go on CSR1 and I'm going to go to router BGP 100 address family IPv4 VRF. I'm sorry, address family IPv4 unicast. No, it's the VRF. IPv4 unicast VRF C1. And I would type a network of 10.1.1.1 mask of /32. And then I'm going to go over to XRV9 and do show BGP VPN v4 unicast. Now I see this the loopback coming across as a BGP route. So router BGP 100 VRF C1 address family IPv4 unicast and network of 10.1.1.9/32. I'm going to commit that. I'm going to go back over to CSR1, do show BGP VPN v4 unicast all, and now we should see momentarily, it should take a couple of seconds for it to propagate, but what we should see is a 10.1.1.9/32 coming from 9. It hasn't shown up yet, but I'm sure it will. Did I commit it? Yes, I committed it. So we are propagating it. CSR1 might just take a couple seconds for it to see. Does CSR4 see it? He sees it. CSR1 just might, there it goes. So CSR1 now sees it, and that's what we need to have. So now what we're going to go do is we need to go and form a peering loopback to loopback. So CSR1 loopback 1 to XRV9 loopback 1, and we need to go and form a control plane peering via OSPF for that. So to do that, we're going to go back to router OSPF 10 VRF C1 and type in area 0, and it's going to be Sham link, and the source is going to be 10.1.1.1, and the destination is going to be 10.1.1.9. Now there's other options that I can throw in here. I can do a TTL security, I can do the cost value and stuff like that. I'm going to go over to XRV9. I'm going to go to global config, router OSPF 10 VRF C1, and I'm going to type in area 0. I'm going to type in sham link, and the local is going to be 10.1.1.9, and the remote is going to be 10.1.1.1. And again, there's other options I can do, authentication, so on and so forth. So I'm just going to go ahead here and commit the config. And you can see that the sham link comes up almost right away. If we look at CSR1, we have the sham link is there now. If we look at the show IP OSPF neighbors, we can see that there is a point-to-point connection to R9 or XRV9 via the sham link, right? So that's the way we want the traffic to look. So now that we have that, what we need to go do on R13 now is look at the show IP route. And the show IP route, now one thing we're gonna see is this E2 route. I will work on those here in just a moment. I want you to more or less pay attention to the path that we have. So if we do a show IP show IP OSPF database, we're going to see some external type 2 routes and stuff like that. Now what we want to do is we want to modify the routing to point us out a different direction. So what I need to do is I need to go to interface gig0/1 and type in IP OSPF cost of 100. Just do something higher, and then we're going to do the same thing on this guy. So we're going to go to global config. Actually, let me show IP route. We should see those prefixes showing up, which we do. We see the 10 and then the 10 and then the 1. Or these two routes right here. I'm going to go to global config and type interface gig0/1 IP OSPF cost of 100. Now that I've done that, if we go back to R13, show IP route, what we should see, and the way we should go about this, is you'll notice that to get to the 10.1.14 prefix right here, you'll notice that I should go out the gig0/0 connection, which is going to be my connection to CSR1. Now if we go back to up here, when we did the trace route before we did all config, you notice how, notice how we went directly to R14 across this backdoor link. We went 10, 13, 14, 14, which is this circuit right here. Well, in order for this to work, we now need to do another trace route. Notice the path we take now is through the MPLS backbone. So we go that direction. I go over to 14, I do the same thing. If I look at the show IP route now, you're going to see that 10.1.13 now goes out towards gig0/0. And that's what you'd want to see. So that is how you do a sham link. The sham link now allows me to modify what's going on. Now, for example, if this circuit right here between 14 and XRV9 went down, or MPLS wasn't available, what's going to end up happening is I'm going to go and the adjacency fails, or the route is lost through that particular path. Then it's just a matter of doing some quick recalculation, and now I'm going to send my traffic towards the backdoor link, this connection between 13 and 14, in order for that to happen. And that's really the driver here that we're looking to have. There might be some reason why you want to go this particular path over the point-to-point connection. Whatever that might be is up to you and how you make that. Now, I have known some other folks that do IT, specifically networking, a friend of mine actually, who had walked into an environment that had this set up, and I had nothing to do with it. I'll tell you that right now. During a conversation with him, he had a sham link. I forget what the RFC value is for this. I'll look it up here in just a second. But he had a sham link set up between, or the provider he was peering with, I should say, had a sham link set up, and he ended up tearing that down and keeping the routing internal. So that's how that worked. And I believe, let me do a quick Google search here. The OSPF Sham link RFC, and that RFC is 4557, where basically when you're looking at that output, let me go ahead and just bring this over real quick. It's OSPF as the provider customer edge routing protocol for BGP, MPLS. Actually, sorry, you're on the wrong screen. For MPLS VPNs, and the idea is you have intra-area external routes, loop prevention, and stuff like that. The down bit, possible loops that could potentially occur, creating the sham link, and stuff like that. So you're basically changing the mechanism for how OSPF is going to do things. We're now saying, you know what, I don't want you to go this path here. I want you to take this path here and go that route. And that's how I want you to forward your traffic. So is it more efficient? It might be. But in terms of what's happening, that's the configuration. Pretty straightforward stuff, but it definitely needs to be tested and understood and known about in order for you guys to do what you need to do. Now, in terms of the remaining issue, we have these prefixes that are being leaked. So these are provider connections that we may not want to allow to be advertised. So let's go ahead and take a look at how we can fix that. So on CSR1, we have this route that's being advertised, and we don't want that prefix to be leaked from the service provider into the customer. And so we're going to go ahead and work on getting that squared away right now. It actually reminded me that I never got the OSPFv3 sham link operational. So let's take a look at the router OSPFv3 10 address family IPv6 and VRFC1 and the area 0 and the sham link, and we're going to do the same thing. So the other thing that we have to take a look at here is that loopback address. So to work correctly, we have to go and we have to interface loopback 1, do show run interface loopback 1. We don't have an IPv6 address. So we're typing IPv6 address is going to be 10:1:1:1/128. And then we're going to go do the same thing on XR. Let's go and advertise this to BGP. So router BGP 100, address family IPv6 VRF C1, network of 10:1:1:1/128. And then we're going to go over to XRv9, do the same thing. So we're going to type in root, interface loopback 1, IPv6 address is going to be 10:1:1:1:9/128. And then we're going to type in router BGP 100, VRFC1, address family IPv6 unicast, and network of 10:1:1:9/128. We're going to go ahead and commit those configs. CSR1 should now do show BGP VPNv4 or VPNv6 unicast all. We should see after a short period of time that the 10:1:1:9 prefix comes across. It has not done so yet. If we look at CSR4 and do a show BGP VPNv6 unicast all, we see it being propagated. CSR1 should now see it, which he does now. So now that I've seen that, I can go type in router OSPFv3 10 address family IPv6 VRFC1 and type in area 0 sham link, and it's going to be 10:1:1:1 to 10:1:1:1:9, and there we go. Let's go over to XR9 and do the same thing. So router OSPFv3 10 VRFC1 area 0 and sham link, and the local endpoint is going to be 10:1:1:1:9, and the remote is going to be 10:1:1:1:1. I'm going to go ahead and I'm going to commit that, and you see the sham link comes on right away. Now if we go down to 13 and we show IPv6 route OSPF, we're going to see this route still being learned, this prefix still being learned via gig 0/1, which is this connection right here. We have to modify the value to be different. So we're going to type in interface gig 0/1 OSPFv3 cost is going to be a value of 10 or 100, sorry. We'll do a show IPv6 route, and now after it recalculates itself, that should change to be, this should go point itself out gig 0/0, which it is. Now it's pointing out gig 0/0. So let's go do the same thing. Look at 14. Show IPv6 route OSPF, and we're seeing that we should point towards 10:1:13 via gig 0/1. let's go switch this guy out and type in interface gig0/1 OSPF cost, or I'm sorry, OSPFv3 cost is 100. And we'll take a look at that route again, and after a short period of time, that will flip over to be gig0/0. Everything is gig0/0. So now we'll do a trace route, IPv6 to 10:1:13:13. The source is going to be 10:1:14:14. We are going to do a numeric display output, and the path will take us through the backdoor link, which is what we'd expect it to show up as. So that's basically how that's coming into play. So it is coming in, yeah, so that's working as it's expected to. And that's really what we want to pay attention to and understand. So I neglected to do that earlier. So that's how that comes into play. So now we're going to go back to earlier, and we're going to go and let me just verify the sham link here, show OSPFv3 neighbor, and or should say OSPFv3 VRFC1 neighbor, and we have the sham link is set up to XRB9. So now we're going to go back and we're going to work on the redistribution problem. So right now we still on R13 we still have these prefixes being leaked. So basically we want to prevent BGP learned routes from being propagated. So in order to fix this, we need to match on the IPv4 and IPv6 prefixes, and then we need to, when we're doing the redistribution of BGP into OSPF, we need to go and prevent those routes from getting leaked. Now I've ran into some problems in the past with this. So I'm going to show you some issues that I ran into just so you're aware of some stuff, and then we're going to go work through it and how to fix them. So I'm going to go to CSR1 first. I'm going to go to global config and type in the IP prefix list. We'll type in PL sham link, and then we'll type in permit, and I'm going to be specific to what it is that I'm going to permit. So it'll be 10.1.1.1/32. And when we go to do this, we're going to use a route map, and that route map is actually going to be used to deny the traffic. And that's basically how we're going to go forward with this. So I'm going to go, the next step we need to go do is an IPv6 prefix list called PL sham link. And we're going to permit 10:1:1:1/128, and we're going to type in route dash map is going to be route map sham link, and we're going to deny, this one's going to be a sequence number, we'll say 10, and we'll type in deny, or is it deny and 10. We're going to type in match IP address in prefix list PL sham link, and then that'll be this one. And then we're going to hit another one. This one here is going to be a permit 20, and we're not going to match on anything. And you might say, well, why aren't we matching on anything? Well, we want to allow everything else. So we only want to match on what we want to. We're matching specifically on this prefix list to match the loopback address. We don't want to redistribute the loopback to be advertised into BGP into OSPF. We want to keep the provider-specific interfaces out of the whole mix. So what I'm going to go do now is a route dash map for RM sham link v6, and it's going to be a deny 10 and match on IPv6 address and prefix list, and this one here is going to be this guy here. We're going to match on that, and then hit the up arrow and do a permit 20. Now if we jump out of global config and do a show IP prefix list detail, we're looking for hits on this. So the prefix list should have a hit at some point in the future, and what will end up happening is this hit count will increment. And so what I should be able to do is when I redistribute BGP into OSPF, that will be the point at which this route map will take effect. So let's go to global config, do show run section OSPF, and you can see how we're redistributing BGP underneath this particular connection. So we're actually going to grab this syntax right here with the subnets command, and we're going to, when we redistribute this, we're going to match on the route map, and the route map name is going to be RM Sham link right here. So we're going to go ahead and apply that, and then we're going to exit out, and then we're going to go grab this OSPFv3 config right here. And when we redistribute BGP 100 and do this, we're going to call a route map of RM Sham link v6 and do that. So we're going to take care of that. Now I'm going to go down to R13. I'm going to hit the up arrow. The routes are still showing up, right? So now what I need to go back to do CSR1 is do the detail. Now you can see it's being hit. There's a reference count towards it. And so that's being matched on. If we do a show IPv6 prefix list detail, the other entry is not being matched on yet. So not that big of a deal, but if we go back to 13, we can, the route's still being propagated from CSR1 down to R13. So it shouldn't be sent down, but it is. If we look at CSR1 and do a show IP route VRFC1, we can still see this route being propagated. So what I'm going to go do is I'm going to go over to XRV9, and we can start working on that side of the house now. So if we go over to XRV, if we go to R14 on this side and we do a show IPv6, or sorry, a show IP route here, these routes are still being learned, right? So it's not being filtered out yet. So what we need to go do on XRV9 is very similar. So sometimes having the, oh, that's, sorry, thought that was something else. Let's look at, so we're going to go to global config, and we're going to create a prefix set. So prefix set, and the name of this guy is going to be PS underscore, and we're going to say IPv4 Sham link, and underneath here we're going to say just the address. So it's going to be 10.1.1/32, and that's going to be the IPv4, so 32. We're going to exit out, hit the up arrow, and do an IPv6 Sham link. And actually, let me do this instead. Let me exit out. And we're going to do a prefix. Well, actually, let me just type a no to this one. I don't like the way that's, the logic for this one doesn't make any sense. So prefix set is going to be PS underscore IPv4 underscore Sham link. And I want to come underneath here and I want to match on 10.1.1.1/32, and I want to go create another one to match on 10.1.1.9. So I'm going to go and do that, and I'm going to come up here and do another one, and we'll do XR9, and we'll come in here and then do this guy, and then we'll exit out. So we're going to have two of them because we don't want to match in the same stuff each time. And so there's that piece. Now, the one thing on CSR1, if we do a show IP prefix list, we're matching on just 10.1.1. But if I come in here and I go IP prefix list PL Sham link, and I do a sequence of 10, and I do a permit 10, and I do a 10.1.1.9/32. Permit 10.1.1.9/32, and do that. And then I look at the show IP prefix list detail. Now we have hits there, so theoretically speaking, that should start getting rid of show IP route OSPF. Of course, I would mistype it. If we do a show IP route OSPF, notice how we've gotten rid of the 10 that the .9 is no longer being matched on. If we do the show IPv6 route OSPF, but the 9 is coming through in this one, we need to go back to CSR1 and go to the show IPv6 prefix list, and we need to go in here and type an IPv6 prefix list, and this one's going to be PL Sham link, and we're going to say permit, and we're going to say 10:1:1:9/128, and then we'll give that a couple seconds to filter. We'll look at that one, and we look at the detail. Now that one should get matches, which it is. If we go back to 13, we hit the up arrow, and now that route's being filtered. So the problem we're trying to solve is we're not trying to block the local link on CSR1. We're not trying to block the .1/32 loopback. We're trying to block .9 from being redistributed back into OSPF. So we need to do the exact same thing on XRV9. I wanted to show you that difference because that's how you're going to filter this stuff out. So if we show config so far, we've matched on 1, and that's the one we need to do. So I'm actually going to go and get rid of this one here because we don't need that one. We need to match on the prefix set of PS IPv6 sham link, and we need to say 10:1:1:1/128, exit out of here. If we do a show config, now we have these two being matched on, which is what we want, and then we can call that from an RPL. So route dash policy of RPL underscore, we'll call this sham link, and underneath here we'll say if the destination is in, and we're going to say IPv4 sham link, then drop, else pass, and end if, and we're going to exit out here. We'll do a show config, and our syntax is pretty straightforward. We're going to say create an RPL sham link. If the destination is in the IPv4 sham link, then drop it, else pass everything, which is no different than the route map configuration we already did. The last step we need to do is create another RPL sham link, but we're going to call this one underscore IPv6. We'll say if the destination is in, and we're going to say PS IPv6 sham link, then drop, else pass, end if, and exit out. We do a show config. That's going to be our syntax. Now we have to take the RPLs and map them to the OSPF version 2 and version 3 redistribution of BGP. So router OSPF 10 VRFC1 for redistribution of BGP 100, we want to call the RPL route policy of, and we're going to call this RPL right here, RPL sham link. There's that, and then we're going to go exit out to router OSPFv3 10 VRFC1 and redistribute BGP 100, and then we're going to call this RPL right here, and then we're going to specify this sham link right here, RPL sham link IPv6, and hit the enter key. So this is our full config. This one's a little bit more involved because of all the moving parts. So we have our prefix sets configured here to match on the CSR1 loopback. So I got distracted for a moment. I had to pause the video, so I apologize. So let me go ahead and rehash the config just so you guys are all on the same page. So the prefix set is calling the loopback of CSR1 that's used for the sham link endpoint, which is 10.1.1.1/32 and 10:1:1:1/1/128. Now we call those prefix sets from the RPL, and the RPL calls them, and it says if this is the IP address, go ahead and drop the redistribution capability. If it is not anything else, just go ahead and allow it to pass through. We do that for both IPv4 and IPv6, and then for OSPF version 2, we call the IPv4 RPL for the redistribution of BGP, and for OSPF version 3, we call the IPv6. So I'm going to basically log back in. I'm going to go to global config, and I'm going to selectively add these commands back in. So let me go ahead and grab these two lines of config and drop them in. And then the next set we're going to do is going to be the RPL, calling those two. And then we'll just go back over real quick for a quick second, just to make sure everybody's on the same page. And lastly, we have the redistribution policy, like that. And we're going to go ahead and dump those commands in like so. So just to rehash those real quick, it's a show config, just so everybody's on the same page. We have the RPL, we have the prefix sets calling the loopback address, the IPv4 and IPv6 address of the loopback one on CSR1. Then the RPL calling the prefix set and dropping those particular host routes for V4 and V6, and then calling those RPLs from OSPF during the redistribution of BGP into OSPF. So we're going to go ahead and we're going to commit those configs. Now that that's squared away, if we go back to R13 now, and we do a show IP route, we're no longer going to see the 10.1.1.9, and if we do a show IPv6 route, we're no longer going to see 10:1:1:1:9 showing up. So our filtering has worked. Now I've ran into problems in the past with doing that, where I've had to use access lists and things like that. So either one will work. I prefer using the prefix list myself. So let's go ahead and focus on the CSR1 config again. So we have the show IP prefix list detail, where we're calling the 1.1.9, so we technically can get rid of sequence number 5. The same thing with the IPv6 prefix list. We need to call the 10:1:1:1:9/128. We can get rid of sequence number 5. So that's going to be the configuration that you would need. Then we have the route map. So show run section route dash map. We have the route map config. The route, actually, that should be fine. We're denying this prefix list. We're denying 10.1.1.9/32, and we're denying 10:1:1:1:9/128, and then we're permitting everything else. So if we go back to CS router 13 and we do a show IP route OSPF again, and we do a trace route to 10.1.14.14, sourcing from loopback 0 numerically, we take the MPLS backbone path. That in itself is what we're trying to accomplish here. We're trying to make sure that the path is taking the connection to the MPLS backbone, but we don't want to have any additional routes in the routing table that don't need to be there. And that's the key thing that we need to remember here, and I'm trying to convey. So with that being said, this took a little bit. We finally got it done. Thanks so much for stopping by and hanging out with me in this video. And until next time, guys, take it easy.